Example 2, if a rock is thrown upwards with a velocity of, or initial velocity of 10 meters per second, its height in meters t seconds later is given by this equation. Y is the height, 10t minus 1.86 t squared. Find the average velocity over the time interval. Now be careful, this is actually the time interval from t equal 1 to t equal 2. This is not a point, this is an interval. This is from t equal 1 to t equal 1.5. This is from t equal 1 to t equal 1.1, from t equal 1 to t equal 1.01. So you'll notice they all have a t equal 1 to t equal something else. And if I put this on a number line, I notice they're going from 1. On part I, they're going to 2. The second part, they're going to 1.5. The third part, they're going to 1.1, 1.01. Then they're going a lot closer. So this is kind of like this idea we were talking about. You choose 1 and you add an h to it, and then you take half of h and you start getting smaller and smaller so that the slope of the secant will equal the slope of the tangent. I'm going to try that on this trick. So I'm going to try, instead of going by what we did on the last problem, use the calculator. We could use the calculator on this, of course. Running from 1, plugging that in, 10 minus 1.86, that is what? 8.14. And go to answer, 10 times answer minus 1.86 times answer squared. Instead, what I'm going to do, I'm going to say, you know what? Let's say we're going to go from 1. If I plug 1 in, 10 minus 1.86, 10 minus 1.86 is 8.14. And what I'm going to do, I'm going to say, you know what? Let's go from 1 to 1 plus h. So if I plug in 1 plus h, y is going to be 10 times 1 plus h minus 1.86 times 1 plus h squared. That would be 10 plus 10h minus 1.86 into 1 plus 2h plus h squared. That would be 10 plus 10h minus 1.86 minus, what is that? 12, 16, 17, 3.72h minus 1.86h squared. So altogether, it looks like I'm looking at 8.14. What is 10 minus 3.72? 6.28 minus 1.86h. So the y value is all of this mess. Now I know it looks like a lot of work. Oh, that's a 7.6. Okay. And now if I say, you know what, the slope of the secant, that would be y2 minus y1 over x2 minus x1. So basically I took f of 1 plus h minus f of 1 over 1 plus h minus 1. And it might seem like a lot of work. Those cancel out. Factor an h out. 6.76. Let me make sure of that number. If I take 2 times 1.86, 3.72. And 10 minus that is 6.28. Okay, wow, why does it seem like I lost something? So this should have been 6.28. So I'm left with 6.28h minus 1.868 squared over h. Factor h out. Again, this might seem like a lot of work. The slope of the secant is actually 6.28 minus 1.86h. Now, all what I have to do is figure out what h is. So, when I run in part I, I'm running from 1. In I, I'm running to 2. That means if I run from 1, remember I want 1 plus h to equal 2. That means h must be 1. Then the slope of the secant would be 6.28 minus 1.86 times 1. That's simple. It'll be 6.28 minus 1.86 times 1. 4.42. When I go to part 2, h is going to equal, I'm going from 1 to 1.5. So from 1, what do you add to 1 to get 1.5? A 0.5. A 0.5. So that means m equals 6.28 minus 1.86 times a half. $5.35. And for part 3, if you notice, 1.1 from 1 to 1.1, h equals 0.1, m will be 6.28 minus 1.86 times 0.1. That would be 6.094 meters per second. And when I go for part 4, h equals 0.01, m will be 6.2614 meters per second. Well, it's settling down. And when I go for 5, h will be 0.001, m will equal another decimal, 6.27814. So if I ask in the second part, that's A, let me add it. If I was to say in part B, why don't you find me the instantaneous velocity? Well, think about it. Instantaneous velocity was to let h be as close to 0 as possible. So if I let h equal 0, guess what the slope will be? And that's allowed if you really find the formula in terms of whatever a is, which is 1 in this case plus h, and find the formula accordingly. And that's pretty much it for this section.